This video is talking about excuse me, global max and minimum examples. And the difference here between what we've been doing is we've been doing local max and min problems. This is global. Now before we even start, the other thing that I want to tell you is, before we get started, is another way is you hear the word absolute interchangeably with global. They both mean the same thing. This is the absolute max and min of a problem. The first thing I want you to recognize is I have an interval. This problem that I have right now, this function, has endpoints. That's the first time you've seen that. Usually they show that they're either arrows and it continues on. So if we want to find the absolute max and min, or the global max and min, what you do is you first do the normal thing with critical points. You're going to find critical points like we've done before. Okay? But the difference is when you find the critical points, you're saying, okay, are these max and mins? They could be local, they could be global. But the additional thing you have to do after you find the critical points is to evaluate the end points of this interval. So you've got to evaluate when x is 1 and x is e squared. You have to evaluate the endpoints to see if they are lower than what you found. Okay, so let's look at this picture right here. I can tell you right now, looking at this function right here, if this is all there is, okay, the absolute min of this problem is going to be right here. That's the lowest point on the graph. The absolute max is going to be right here because that's the highest. So let's do some of the algebra to go with this. So let's do f prime of x here. Here's my f and my g. So it's going to be f prime g, so that's 10 times 2 minus ln x, plus f g prime, so that's going to be 10x times 1 over x. So I have f prime of x is going to be, the x's cancel out here. Let's factor out the 10. So I have 2 minus ln x minus 1. So f prime of x in this case is going to be 10 times 1 minus ln x. We put that equal to 0. 10 will never equal 0, so thanks for your help. But 1 minus natural log of x equals 0. The natural log of x is going to equal 1. Base e, e to the first equals x, so x is going to equal e. So, and if we look at our graph, if I have an e for my x value, if I plugged it back into the original, I'm going to get 10e. So there is, looks like it's a critical point on our graph. All right, and if you were to look at it, you can tell it's going to be an absolute max. So it's 10e, and you know e is 2.71 or whatever. Okay, now the other part we have is, now since we've come part this and we think this is going to be either an absolute or a global max, is now we have to evaluate the endpoints. So the other endpoint of this graph is when x is 1. So when I have to figure out what f of 1 is, and when I put f of 1 in, I get 20, so there's the point 120. And 120 is lower than this, so that is not going to be a max. And then I actually have to evaluate the other endpoint, which is f of e squared, and when I plug in e squared back into there, I get 0. So the other point is e squared 0. So after I find our normal, this is our critical point here, and we can check to see if it's bigger or smaller, this actually comes out to be an absolute, or if you wish, a global max. Okay? And this is a local max, but this is our global min because it's the lowest point on our graph. Okay, I just wanted to show you how there is a little bit of difference. You have to have the endpoints evaluated to make sure. Okay, so let's look at one more of these. So I have this weird little function here, and this is an absolute min. You can tell by looking at the graph. It's also a local min. Here I've got 2 points. This looks like an absolute max, and this looks like a local max. So let's do our derivative. So I have f prime of x equals 2/3 x to the negative 1/3, and put it equal to 0. Now our interval here, if you'll see, is on negative 2, 3. So I've got to evaluate the endpoints too. So I'm going to divide by 2/3 on each side. So I have x to the negative 1/3 equals 0. Raise it to the negative 3, I have x equals 0. which in this case, if I plugged it back in, would be the 0.00. Okay? So that is going to be our absolute or global min, if you will. All right? Then after I evaluate the other points, like f of -2, to find out what that would be, it's not very pretty, but it's about a -1.587. So that is 1 point on our graph. And then if I found f of 3, because I have to evaluate the endpoints, that also is not pretty. It's about 2.08008. So it's 3, 2.08008. So if we were going to look at what would be the absolute max, this one looks like the highest point there is. So this is going to be our global max in this problem. Okay? So now this is what you've got, and I just wanted to show you a couple problems where how it's a little bit different when you have an absolute or a global max or min.